In the middle of the American desert, a building rises that looks more like a spaceship hangar than a factory. Inside, the air is cleaner than a hospital operating room, and the machines cost more than most jet aircraft. This is not an ordinary construction project. It is one of the most advanced factories ever built on American soil. Billions of dollars, thousands of engineers, and years of planning have gone into a single mission, bringing back the most important technology of the modern age. Inside this building, silicon wafers thinner than a human hair are transformed into the brains of nearly every device we use. Smartphones, cars, satellites, hospital equipment, and even fighter jets all depend on what happens inside factories like this one. This is the story of America's $10 billion chip factory, and why it could reshape the future of technology. But how did a factory become more important than gold, oil, or even military power? For decades, most advanced semiconductor chips were manufactured overseas, far from American soil. As global demand for chips exploded, countries realized that whoever controls chip production controls the future of technology. The COVID-19 pandemic exposed a serious weakness. A shortage of chips slowed down car production, electronics, and even medical devices worldwide. Researchers and policymakers began asking a critical question: what happens if chip supply chains are disrupted again? This concern pushed American companies and the government to invest heavily in rebuilding domestic chip manufacturing. The goal was not just economic growth, but also national security and technological independence. Building a chip factory, however, is far from simple. It requires extreme precision, massive investment, and years of preparation. That is exactly what makes this $10 billion facility so remarkable. At its core, a semiconductor factory transforms raw silicon into complex chips using an incredibly precise process. It begins with silicon wafers, thin discs cut from purified silicon crystals. These wafers are coated with chemicals and exposed to light patterns using a process called photolithography. Photolithography allows engineers to carve circuit patterns thousands of times smaller than a human hair. Some of the most advanced machines used in this process are made by companies specializing in extreme ultraviolet lithography. These machines use light with an extremely short wavelength to draw incredibly small transistor patterns onto the silicon. Each wafer may go through hundreds of processing steps before it becomes a finished chip. Any speck of dust could ruin an entire wafer, which is why the factory floor, known as a clean room, is kept almost completely free of particles. Workers wear full protective suits, often called bunny suits, to prevent contamination. Robotic systems move wafers between machines to avoid human error and maintain precision. Temperature, humidity, and even vibrations from footsteps are carefully controlled throughout the facility. Once finished, each wafer contains hundreds of tiny chips, later cut apart and tested individually. These chips can then contain billions of microscopic transistors, switching on and off billions of times per second. This incredible complexity is what allows a chip smaller than a fingernail to power an entire computer. The impact of this factory extends far beyond the technology industry alone. Advanced chips are essential for artificial intelligence systems, which require massive computing power to function. The automotive industry also depends heavily on semiconductors, especially as vehicles become more automated and electric. Modern hospitals rely on chips for medical imaging devices, diagnostic tools, and life-saving equipment. Even national defense systems, including satellites and communication networks, depend on secure and reliable chip supplies. Economically, a single advanced chip factory can create thousands of high-skilled jobs in engineering, research, and manufacturing. It can also encourage related industries, such as chemical suppliers and equipment manufacturers, to build operations nearby. This creates what experts call a semiconductor ecosystem, where multiple industries support and strengthen one another. On a national level, domestic chip production could reduce dependence on foreign supply chains during global crises. This may improve resilience against future shortages, whether caused by pandemics, natural disasters, or geopolitical tension. In the long term, this factory could serve as a model for how nations build strategic technological independence. The success of this facility could also influence how other countries approach semiconductor manufacturing in the future. Despite its impressive scale, this factory faces serious engineering and economic challenges. Building advanced chip factories requires specialized machines that are extremely limited in global supply. Some of these machines take months to manufacture and require highly trained technicians to operate correctly. Training a skilled workforce is another major challenge, since semiconductor engineering requires years of specialized education. Many experts note that the United States currently faces a shortage of engineers trained specifically in chip fabrication. Construction costs remain extremely high, and delays can occur due to supply chain issues or technical setbacks. Energy consumption is another concern, as these facilities require enormous and consistent power supplies. Water usage is also significant, since the manufacturing process requires large amounts of ultra-pure water for cleaning wafers. Environmental engineers are working to develop more sustainable water recycling systems within these facilities. Global competition adds further pressure, as other countries continue investing heavily in their own semiconductor industries. Maintaining technological leadership requires continuous innovation, not just a one-time investment. Researchers acknowledge that scaling up production while maintaining precision remains an ongoing challenge. Looking ahead, this factory could represent just the beginning of a larger transformation in American manufacturing. Engineers are already exploring next-generation chip designs that could push computing power even further. Some researchers are studying new materials beyond silicon that could improve chip performance and efficiency. Advanced packaging techniques may allow multiple chips to work together more efficiently, potentially improving speed and reducing energy use. As artificial intelligence continues to grow, demand for more powerful and efficient chips is expected to increase significantly. This could lead to even larger investments in domestic semiconductor infrastructure in the coming years. Government programs and private companies may continue collaborating to expand chip manufacturing capacity across the country. If successful, these efforts could help strengthen America's position in the global technology landscape. However, experts caution that consistent investment, skilled workforce development, and innovation will all be necessary for long-term success. The next decade could determine whether this facility becomes the foundation of a new era in American manufacturing. What began as an ambitious $10 billion project has become a symbol of technological ambition and national resilience. Inside this factory, silicon and light are transformed into the invisible engines that power modern life. It represents not just an investment in machines, but an investment in engineers, innovation, and the future itself. While challenges remain, this facility shows what is possible when science, industry, and determination come together. As global competition intensifies, projects like this could shape the next chapter of technological progress. And as the world watches, one truth becomes clear: the future of technology may very well be built right here, one chip at a time.